Gentlemen, we're now learning the law of cosines. We got to the situation when we did number 26 in the book. Or sorry, not number 26, number 19, which we're going to come back and solve in just a moment. So here we go. This is actually what the law of cosines is. If this is a more difficult proof than the one that we did with the law of sines. This one is heavily algebraic. If you get lost, it's okay. You'll need to memorize the law of cosines at the end, but I do always feel like it's necessary to explain the why so you guys understand the what in each of these scenarios. So again, we have triangle ABC, meaning that here we have this side, which is lowercase a, this side, which is lowercase b, and of course this last side, which is lowercase c. All right, so just a little notation point. Make my A look a little bit better here as I'm just looking at this. We're going to drop another altitude, just like we did when we did the proof for the law of sines. Okay, so here's our altitude, and this is at D. Okay, now the question then becomes, if we're going to solve for this side right here, side AD, okay, this, where we have, let's take the angle A, the cosine of capital A, right, is going to be equal to the adjacent side, which is AD, over the hypotenuse of that triangle, which is B. So if I were to solve for AD, I'd multiply both sides by B, giving me that this would be B times the cosine of A for that length. That's the length of that side, okay? Same thing if I'm going to now look at this triangle right here, BDC, okay? BD is going to be equal to A times the cosine of B. So that if I'm going to express C, C is going to be equal to the sum of those two segments through segment addition. A times the cosine of B plus B times the cosine of A. Now, just another way to express this, let's say that we're trying to express this in terms of C squared, right? We can multiply both sides by C, meaning that C times C is C squared. And then, of course, if I'm going to multiply this entire thing by C, right, I'm going to distribute C into each of these terms, giving me AC times the cosine of B plus BC times the cosine of A, okay? Just a fun way to express that. Now, we could go angle by angle and accomplish the same exact thing with each side to get B squared and A squared simultaneously, okay? So B squared, watch what's going to happen. B squared is going to be, where C squared is AC cosine B, BC cosine A. There's actually a similar pattern that we're going to negotiate. We're going to have AB times the cosine of C plus BC times the cosine of A, right? Notice that when we're taking that cosine, right, it's going to be multiplied by the two sides that are not included, right? So if it's capital B, the other two sides are AC. So for A squared, right, we're going to go AB times the cosine of capital C plus AC times the cosine of capital B. And remember, for A squared, right, A is going to have to be incorporated to each of these terms. For B squared, B is going to be incorporated to each of these terms. All right, now, just considering where we're at algebraically, we could take A squared and B squared and take a sum of those, right? So I'm curious what A squared plus B squared is going to be, and this is not a right triangle. It's not just going to be C squared. So A squared plus B squared is going to be equal to the sum, right, of those terms that we have right here. So it's going to be AB there's two of these, right? So it's going to be 2AB times the cosine of C plus BC times the cosine of A plus AC times the cosine of B, right? You get the sum of all of those terms. Now, remember, algebraically speaking, we can do anything to both sides as long as we do it to both sides, right? Like I could subtract 1,000,000 from both sides if I wanted to. As long as I do that algebraically, the equations will still balance out, right? Equation equal. So both sides are going to be the same. So hypothetically speaking, let's subtract c squared from both sides, okay? Giving me a squared, a squared plus b squared minus c squared. And I'm going to subtract c squared from this right side. So I have 2ab cosine c. So recopying what I have here, bc cosine a plus ac cosine of b. But look, I'm going to subtract c squared. So look how c squared can also be expressed. It could be expressed like this. So I'm going to subtract off that thing right there. It's going to be subtracting AC cosine of B, just have A cosine B, AC cosine, did it again, goodness, struggling here, AC cosine of B, and I'm also subtracting off BC cosine of A. Now watch what happens here when I do this, right? I have a AC cosine B and an AC cosine B that are both subtracted. Those guys are going to cancel. I also have taken a BC cosine A and I've canceled it out with another BC cosine A, right? So this is what I'm now left with. I suddenly have A squared plus B squared minus C squared equaling 2AB cosine of C, all right? Now I'm going to solve this thing in terms of c squared, right? So to add c squared to both sides here, let's move this guy over. It's going to cancel that guy out on the right, or on the left. So I have a squared plus b squared equaling 2ab cosine of c plus c squared. Of course, solving for c squared, I'm going to subtract 2ab cosine of c from both sides, okay? Let's make sure that we're canceling this guy black. There we go. Leaving me with the following. I have a squared plus b squared minus 2ab times the cosine of c is equaling, last but not least, c squared. Gentlemen, this is the law of cosines, okay? We can express this for every single one of the angles that we have, or every single one of the sides that we have. So law of cosines. Given 3 sides, we can solve for 1 angle, right? Or given 2 of the sides, right? Given 2 of the sides and the thinking about if that included angle C, right? We can solve for the 3rd side, okay? So, law of cosines. We could have a squared plus b squared minus 2 times those 2 sides times the cosine of c is equal to c squared. That's one way to go about it. Okay? I could take b squared, which is going to be a squared plus c squared minus 2ac times the cosine of capital B, and that'll give us b squared. And then thinking about, last but not least, how do we do the other one? Well, we'll take b squared plus c squared minus 2bc times the cosine of a is equal to a squared. And you probably see a pattern, right, of how to achieve those, okay? So, we had effectively like an SAS problem, right? So this is number 19 that you had in your textbook. Number 19 looked like this. Let me redraw it for you, okay? we had ABC. We had 7, and we had 9, and this guy's 35 degrees, right? And we're going to go to our solution box here. And we are looking for angle B, we're looking for angle C, and then we are also looking for lowercase a. Okay? This guy is equal to lowercase c, and this guy here is equal to lowercase b. So let's find lowercase a. Okay? Because right now we don't have a way to solve for those other angles or for that other side. Okay? So we could say a squared is equal to, remember, it's going to be b squared plus c squared minus 2bc, right? So that part I think is pretty straightforward, right? And then now we need to figure out it's bc, and then it's the cosine of the angle opposite here, and that's going to be your law of cosines, right? Okay. Now we have all of those components except for a. So it says a squared is equal to 7 squared plus 9 squared minus 2 times 7 times 9 times the cosine of 35. Okay? Now we're going to operate on this entire thing. Algebraically. We're going to solve for a squared. We're going to solve for a, but we need to simplify this before we punch this thing into a calculator, okay? So let's go ahead and simplify all the stuff we put in. This will be 49 plus 81 minus 2 times 7 times 9 times the cosine of 35. 49 plus 81 is 130 minus 126 times the cosine of 35. Now this is where kids get into trouble, right? They want to combine this and this. You can't do that, right? If I had 130 minus 126x, can I subtract the 130 and the 126? I can't, right? So that's just going to stay as it is. And then of course here, we're going to take the square root of both sides, okay? To get a by itself, so a is equal to rad 130 minus 126 times the cosine of 35, okay? Now, we're going to punch that into our calculators here to get an answer. So I'm going to punch it into my calculator right now. 130 minus 126 cosine of 35. And make sure that I put 2 parentheses. I have to close 35, cosine of 35, and then I have to close that entire parentheses inside of the radical. That's going to be completed first, okay? And then when you hit enter here, right, the answer is about 5.17, but you should get about 5.2 when you punch that in, okay? So that's not equal in this case. This is about equal to, all right? Now that we have that, okay, we can actually use the law of sines to really like get us through the rest of this, okay? And that's fine. I'm okay with that. It means that we're going to have an approximation of an approximation, okay? Now, I could go and let's say I could solve for angle B, right? Because I could use B and C. Or I could use A in this case, right? If I solve for angle B, I'm going to use A and C to get, and then B squared. And I could use the law of cosines. But I'm going to actually use the law of sines here, okay? So let's do this. We're going to take the sine of angle B, which is what we're looking for, over B, which is 7. And then we're going to use A now that we have it, okay? Because we have the sine of angle A, which is 35, over our approximation 5.2. And we can absolutely do that. That's okay. We're kind of backed into a corner. It's the best that we can work with right now. Okay, So then I'm going to multiply by 7. I know that the sine of b is equal to 7 times the sine of 35 divided by 5.2. And then I'm going to take the inverse sine of both sides. 7 times the sine of 35 over 5.2. Okay? And angle B, I'm going to punch that into my calculator. Okay? It's going to give me another approximation. But I can enter into my TI calculator that entire term here, okay? And the calculator is going to do the whole thing for me. All right, so I punch that into my calculator and it gives me about 50.5. Now, angle C, I don't have to do a law of sines and cosines. Guys, that one's going to be a little bit more straightforward, okay? So I need to make sure I have that, I need to make sure I have that. But that one is going to be, right, 35 plus 50.5 plus angle C is going to be equal to 180. I'm going to subtract both of those. And I'm going to get 94.5, right, when I solve for C. Which of course is an approximation, okay? And that's how we use the law of cosines. It's a little long, but it's doable nonetheless, right? So there's no triangle that we're really, and there's an ambiguous case here. We haven't gotten into that. We're not going to tackle that here. But you know, there's not a calculator, or there's not a problem that we're really restrained from solving at this point. So even when we use the law of cosines, we can still have to use the law of sines. So let's do one more example here for today. Let's solve this triangle, okay? Where I have lowercase a is 30, lowercase b is 27, and lowercase c is 18, okay? Now, what would that actually look like, okay, just in case you're curious? The diagram, if I were to draw that, right, and I've got A, B, C, right? Lowercase a is going to be this side right here, right? That's going to be side BC, and that guy's going to be 30. Lowercase b, 27, and then this guy's going to be 18. That's just what this guy looks like, just in case we were curious, okay? But I need that room to work. And I don't really need to know what it looks like, because I know what I'm solving for. I'm solving for angle A, I'm solving for angle B, and I'm solving for angle C. And none of these are actually going to be equal. They're all going to be approximations when I get there. Okay? And unfortunately, we're going to have an approximation of an approximation. You could enter, I think some of you guys think, well, was there a way that we could do this without actually dealing with an approximation, right? There actually is a way. It's not too terrible. But I'm gonna spare you guys with that right now. So let's solve for, I don't know which way you guys want to do it. Let's do b squared, okay? Let's go across the, oh, I'm sorry, you know, let's find across the longest side. Let's find angle A. And if we're finding angle A, we're going to find this in terms of a squared, right? So it's going to be a squared plus, is equal to b squared plus c squared minus 2bc, right? Times the cosine of angle A, right? And I know that this and this are related, right? So just kind of as I sit here and memorize this, a squared, so we're going to say 30 squared is equal to 27 squared plus 18 squared minus 2 times 27 times 18, and that's equal to the cosine of angle A, okay? It's going to be a lot of calculator work here. So 30 squared is 900, right? So 27 squared which is 729, plus 18 squared, which is 324, minus 2 times 27 times 18, it's 972 times the cosine of angle A. All right? So I have 900 is equal to, I'm going to take that sum of 729 and 324. I got 1053 minus 972 times the cosine of A. And I hope you guys aren't getting worried here because I'm solving for A. I got to get that by itself. So I have to get rid of this term right here. So I'm going to subtract it from both sides. Okay, this is going to cancel. 900 minus 1053 is negative 153. Okay, equaling negative 972 times the cosine of A. Now I've got some negatives here, right? And that usually doesn't work out for me, but it's okay. It's all right. Watch, because I'm going to divide by negative on both sides. It's going to straighten itself out here. So I'm going to have 153 positive 1. Oops. Goodness, guys. Sorry. My tablet, as you know, is especially sensitive these days. 153 over 927 is equal to the cosine of A. I'm going to take the inverse cosine of both sides. Okay. So I'm going to have the inverse cosine of this fraction is going to be equal to angle A. This is my answer. Now I'm going to punch that into my calculator so I get my approximation, right? So I have A. I'll take the inverse cosine and have that fraction 153 divided by 927. Okay. For the record, you can simplify that, but I don't really care to. It doesn't really matter if I do. And I'm going to get 80.5 degrees. Okay, now there's going to be so much variation here depending on what you're going to solve for first. If you solve for B or if you solve for whatever. Okay, so there's going to be some room, some wiggle room here. As long as you might check your answer with the textbook. Like for example, the textbook says that the answer is 80.9. And because of the rounding errors, right? Because sometimes we're taking approximations of the approximations, or we're solving for angle B first or angle C first. It's going to vary. So if you're within a degree, I actually will take that answer. Okay, so plus minus like a degree will be okay. All right. So continuing on, let's find angle B, right? So we're going to take the sine of B over 27 is going to be equal to the sine of angle A, which is 80.5 over A, which is 30. Okay, so then I'm going to have the sine of B is equal to 27 times the sine of 80.5 over 30. Then I'm going to take the inverse sine of both sides. We're going to put this whole thing inside of it. Okay, so angle B is about equal to, once I punch it into the calculator, inverse sine, 27 times the sine of 80.5. You divide that by 30. And that's going to give me about 62.5, okay? And of course, I'm just going to subtract those from 180, right? I'm going to have 180. 62.5 plus 80.5 plus angle C, and that's going to be 180, right? And that's going to, the difference, which of course is going to be 37. It's about equal to 37. Textbook has 36.4, but this is, because of all the rounding that I've done, this is what I've got. So of course my approximations are actually going to be just fine. And there it is, the law of cosines. A few of these problems for tonight. The best part is when you do law of cosines and solving a triangle, you wind up having to use the law of sines anyway, okay? So you do need to learn how to use both. That's all I've got for you. If you have any questions, go ahead and reach out to me via email. You still have your test just coming up right around the corner. Good luck.